Hello, welcome to the video on trigonometric ratios. This is our first example set A. And of course, I hope you had a chance to watch the lesson. And if you did watch the lesson, you know that we covered a good amount of material in it. And I suggested to watch that lesson probably even 2 times was a good idea. But what we're going to do here is just kind of practice some of the basic concepts we learned in the lesson. And one of the things I want you to keep in mind was that saying that we learned. Okay, remember that saying, Sohcahtoa, okay? Sohcahtoa. This is a mnemonic, a little memory aid to help us remember the ratios, these trigonometric ratios, sine, cosine, and tangent. Okay, so let's go ahead and start practicing applying Sohcahtoa by setting up these ratios with the following. Okay, so here we're asked to write the tangent of angle y. Okay, so here's angle y. So the tangent, just a quick review here, I would be using the TOA, right? Okay, that's our saying, that's how it goes. So tangent, or TOA, is equal to, the tangent is equal to the opposite over the adjacent. Okay, that's your TOA, T-O-A, okay? So here, this is really quite easy if you can properly identify the opposite and adjacent sides. Okay, and now we're talking about the opposite and adjacent sides with respect to angle y. Okay, so here 8, that's going to be the opposite side, and the adjacent side of angle y, the one that's kind of connecting with angle y, is 15. Okay, so very simply, the tangent of angle y is its opposite over adjacent, or 8 over 15. Okay, now you could go ahead and simplify that into a decimal, but that's not necessary. My focus here is just to get you to be able to set up these ratios. All right, so now let's go ahead and move on to our next one. So we're dealing with cosine, so we're going to be thinking about the ca. All right, so if you're saying, okay, what is cosine again? So just remember ca. Sohcahtoa, so cosine is equal to the adjacent over the hypotenuse. And once again, cosine of angle x, here's my angle, okay? 24 is the adjacent side, and the hypotenuse, of course, is going to be this side. So let's go ahead and set that up. So cosine of angle x will be 24 over 25. Okay, really, I mean, should be pretty easy, especially with a little memory aid. So now we'll go ahead and do sine. So you're saying, okay, which one is sine? Just go back to Sohcahtoa. So it's going to be S-O-H. So that's going to be the opposite over the hypotenuse. Okay, now which one is the opposite? Well, we're talking about this angle here. So once again, that reference angle is still in that corner. So the opposite will be y. Okay, and then of course, the hypotenuse here is labeled as r. Okay, so the sine of theta, that's by the way how we pronounce that little variable, is the opposite, which is y, over the hypotenuse, which is r. So y over r. Okay, so let's move on to tangent. Okay, once again, this is pretty easy, hopefully. So this is TOA, the opposite over the adjacent. So now here, my angle's in this corner now. So what is the opposite side? Okay, well, this is the opposite side right here. 12 is, okay? And my adjacent side is going to be what? Okay, what's the adjacent side next to angle Z? It's going to be this right here, that X. Okay, so TOA is the opposite over the adjacent, or in this case, it'd be 12 over X. Okay. All right, so this might seem kind of basic for you and fundamental, but let's just make sure you have these core concepts down before we really start doing more with trigonometry. Okay, how about this one here? Okay, now we have cosine of 30 degrees. So here, 30 degrees is located here. So we have to really kind of think of where the opposite, the adjacent, and the hypotenuse is located. So cosine, once again, is associated with ca. So that'll be the adjacent side over the hypotenuse. Okay, so which one is the adjacent side here? Okay, 30 degrees. This side is the adjacent, and the hypotenuse, of course, is this side, which is 2n. So now let's just go ahead and fill in those variable expressions for our adjacent and hypotenuse, and we'll get this. We'll get n over the square root of 3. Okay, that's my adjacent side, and my hypotenuse is 2n. Okay. Now at this point in time, you're looking at that and saying, well, that's pretty good, but you can actually simplify this even further by cross-canceling these ends. So you have the square root of 3 over 2. Okay, so cosine 30 degrees equals square root of 3 over 2. All right. By the way, let's just do a little quick experiment because we are going to be talking about using our calculator next. Let's go ahead and just test something here. Let's go ahead and find out what the cosine of 30 is using our calculator. A little bonus problem here. Okay, so I'm getting 0.866025. Okay, so if I type that in, 0.866025, let's see if this works out. Okay, let's see if this is in fact a right triangle. Okay, if these measurements were appropriate. So I'm going to go and find out what the square root of 3 is, and I'm going to divide it by 2. Okay, it's a good little exercise to make sure you know how to use your calculator. So square root of 3, I'm getting as 1.732 or so. And I'll take that, I'll divide it by 2. Okay, and lo and behold, you get something pretty close to this. Okay, so it worked out. So what we're doing here, okay, is kind of verifying that this particular triangle is a right triangle. Remember that these ratios, these trigonometric ratios, are all associated with right triangles. Okay, not any triangle, with a right triangle. So kind of even as a bonus here, you should recognize that this is a 30, 60, 90 right triangle. You can see the ratios. If you recall back studying those special right triangles, this all makes sense. Okay, so moving on. So if you're understanding you got everything right so far, then you're really in a good spot. So now what I did is I went ahead and actually calculated these particular values on my calculator. So let's just go ahead and give them to you real quick. So things that could go wrong: 1, you could go fast, too fast. 2, your calculator may not be in degree mode. Okay, so these are 2 things that could cause you to get the wrong answer. Or I guess the third thing is not really understanding what's going on. Okay, so here, tangent of 70 degrees. Here's your answer there. I'll spare you the pain of me rattling out all these decimals and stuff. So 36, sine of 36 is this, cosine 17 is this. Now, one thing I do want to just remind you here is this notation is called, oftentimes it's called the arctangent or arcsine or arccosine or inverse, the inverse tangent, inverse sine, inverse cosine. When I learned this way back many years ago, it's kind of stuck with me, as the arctangent or arcsine, arccosine. Both are kind of interchangeable terms, but just remember this right here. What it's doing is we have the tangent -1 or inverse tangent or arctangent of this amount. But what you're really doing is asking your calculator what angle has a tangent of 1.9626. Okay, and when you hit enter, the answer your calculator is going to get back to you, especially if it's in degree mode, okay, is the degree. So here it's going to be 62.99 degrees. So you should have that degree notation there, okay, for these arc functions or inverse trigonometric functions. Okay, so down here, these last 3 problems, here's the answers. What I wanted to do is just kind of mix it up a little bit, have you multiply some numbers times some trigonometric values, because you're going to be doing some of this in later problem solving. So if you got the right answers here, if you understand everything in this group of problems, you are really setting yourself up nicely to kind of master how to apply and solve what we call right triangle trigonometry problems. Okay, so that's actually really cool, and you should feel very proud of yourself. Okay, so keep working hard. We'll see you soon.